do we have Daryl?
I see him.
I'm here.
Yeah. Hi, Daryl. Okay,
Hi.
great. So let me go ahead and share, and we will get started. So I think, Riza, we'll start with you and any company updates, nonprofit org updates, and then we'll move on to Daryl, our research scientist at Kwaai.
Yeah, fantastic. For the purpose of the recording, it's Friday, November 8th. This is our 67th Kwaai Day. Welcome. Congratulations, everyone. My name's Riza Rasool. I'm chair of Kwaai. Kwaai is a movement that has a mission to democratize AI. We're doing that by building personal AI that is loyal to you, that's not eavesdropping or spying on you, AI that can be truly uplifting for individuals. And we think that that is a better place to start. There are many other participants in the industry that are going after AI for increasing the profits of corporations. Fantastic. It's a lovely red ocean for them to sail in. As a non-profit, we can afford to play the long game. We believe that the real market opportunity, it's a real market opportunity, is in the area of personal AI. It's in the area of personal assistance, agentic AI, and AI that is in service of individuals. Okay, so we formed the movement a year and a half ago. We're now about 680 members strong. 80% of those are developers, and the rest are split between research and policy. We're really excited. I'm going to show you some slides later on, but today we've got a packed agenda. So I'm going to give you back to Myra. And Myra, why don't you talk us through the agenda?
Yep. So as you can see, we're going to talk to Daryl. Daryl is going to talk about, I believe, our research at Kwaai. He is very well versed in the sense of being an author on Gen AI technologies, as well as a speaker. And after that, we'll get work group updates and hear from the community and do member voices. I'd love to meet some of the new members. I know we do have, office hours next week. So I definitely want to see all the new members come there, and, we can talk more about Kwaai and our mission, and also like help you get integrated into the Kwaai Society. So Daryl, it's all you.
Awesome. Thank you very much. Let me go ahead and share my slides. You can see me. Awesome. See me. Great. Yeah. Let's share. Turn this on. Oh, back. Oh, where did Zoom go? Right here. Okay, cool. Okay, can everybody see my screen?
Yeah.
Yeah.
All right, awesome. So yeah, thank you. Thanks for the introduction. And it's really a thrill. I'm really thrilled to have a chance to do a lightning talk on something that's actually been brewing in the AI fundamentals group for quite some time. And when I joined Kwaai back in May, I started diving into exploring a relatively new type of language model that's been making waves in the AI space for over the last 2 years. And it's called like selective state space models, or otherwise known as MAMBA. That's what a lot of people refer to it as. And some of you might recall during a Kwaai session, a few weeks after I joined, I think it was probably within June, July, I did some initial presentation on some of the results, some of the initial insights I gained from the research I was doing at the time. And then since then, a lot has evolved. A lot of work has been evolved over the time. And today I'm going to give you a kind of up-to-speed update on some of the work that I've done, and also introduce you to a kind of a new direction I'm taking with the research. So at a high level, I'm going to learn a couple of things. We're going to learn like a high level understanding of what state space models are, why they're important, why they're relevant to Kwaai. You're also going to learn about state machines because it's in the title. And then I'll talk about the research project I'm doing more, and we share a little bit of opportunity for you guys to get involved if you choose to do so. So in order to understand what exactly state space models are, what finite state machines are, and why they're important, I'm going to take a step back for a minute and talk about the current state of AI, and specifically technologies that are powering the tools that we use and we love today. So whether you're looking at ChatGPT, Mistral, Claude, Grok, they all follow the same underlying architecture. The same underlying neural network architecture comes into play when building these tools, and that's the transformer. So transformers are large language models, and they're typically trained on large amounts of data from the internet. And basically, the way they work, based on the input that they've learned, they're able to generate text that often feels really human-like. And the secret behind the way they work is so the way they work is you have an input sequence. So let's say it's this input text from the bottom here, and you're able to basically predict the next word that follows the input sequence. And they're trained to do that so well it almost looks like it's like human wrote it. But the secret sauce behind the transformers is basically something called an attention mechanism. So each layer, embedded in each layer of the neural network is attention blocks. And the best way to kind of understand how they work is to kind of think about, let's say you're given an input sequence like this. This kitchen smells like rotten. And you want to try to figure out what's the next most probable word that will follow after the sequence. So what you would probably do is you'll take a look at each word, and every word, you'll try to see if you can figure out which words are the most important to focus on in order to predict the next word. So this is essentially what the attention mechanism does. It looks at every word in the input sequence, and it tries to assign varying levels of importance to each word. And by doing that, it's able to focus on particular words in the input sequence that carry the most meaning. And by doing so, so basically each block in the input sequence is calculating a score, is weighing each word in the input sequence based on its relationship to other words, and then it's going to calculate the score for each word, and then in each layer, and that basically allows it to figure out which words that it needs to focus on the most in order to generate text. The next text. So how does this translate to generating text with the model? So we say we have our input sequence here. This kitchen smells like rotten, and then we predict the next probable word, eggs. So this sequence, it generates. So it's okay. So the most important part here is first it's going to go through each word in the input sequence, and it's going to calculate the next probable word that comes after it. And then let's say you want to generate another word that the next word that comes after eggs. So if you're thinking about, let's say another the word that falls after, it's going to go through the entire input sequence again. And then try to calculate the attention scores for each word, and then figure out the next probable, in order to guess the next probable word that comes after that. So the most important point here is that as you increase the number of words, then the size of the words in your input increases. It takes the amount of time that's needed to generate text basically increases along with it. And what does this basically mean in terms of text generation and how these models are used today? So that basically means is that you have to deal with high memory and computational costs. So as the longer the words let's say you're putting text, feeding text into ChatGPT or a model similar to it, the longer the length of the text you put in these models, the more amount of time it takes to generate text, the more amount of memory that's required to generate the text. And this also implies is that when you're deploying these large language models, these large transformers in production, you typically require very expensive hardware. So if you take a look at a model like Bloom, which is 170 billion parameters, you would need about eight high-end GPUs in order to actually use it in production. So that basically amounts to like $15,000 each for each GPU. So that's prohibitively expensive. And not to mention, it's also very high energy consumption, which makes it really prohibitive for, let's say, resource-constrained environments, like for example, smaller phones or even smaller devices that are low powered. You also have to deal with latency issues. So let's say, for example, you're building an application that's more client facing, that they're interacting with a chatbot or doing a search engine that interacts with a transformer model. The longer the size of input that you give these models, the more time that's needed to actually calculate a response. So as you can imagine, this would obviously result in a poor user experience for the user. Could cause churn, dissatisfaction with the product. And then the most biggest issue, and which is something that's more relevant to the mission of Kwaai, is that there's a high barrier of accessibility to using these models. So really the only people that can actually use these large language models are companies that actually have the resources to actually utilize them. So corporations like OpenAI or Google or Meta, only these companies are really able to actually utilize these models to their full potential because they just have the resources to do so. So on top of that, there's also a problem in that these models are black boxes. So when people ask the question, okay, how do these LLMs, how can they actually process their language or even arrive to conclusions? A lot of people are stumped because even though we understand as researchers or creators of these models, we understand how these models are created, how they're structured, the architecture of these models, but really don't understand how the actual processes that they make, they go through to arrive at their decisions. It's still very obscure. And the implications of that is there's a lot of difficulties in really understanding, picking out biases or any errors or flaws that the models can have. They can oftentimes go undetected. We're not able to really identify any problems or inconsistencies in some of the results that are available. I mean, there's methods that we as researchers have to kind of get a sense of how consistent these models are generating results, but we're looking at it more from more of a black box perspective. But we're not really able to really understand the inner workings of the language models and really understand what we're actually doing, how they're actually processing the input we're given and what kind of conclusions they're making from it. So this makes it very difficult for industries, let's say like finance or healthcare, where really being able to understand, we're able to audit these, being able to have some clear explainability on how these models work, so you can actually audit them to make sure they're sound and making ethical decisions for people. These without that understanding, it's really difficult for people in some industries are interested in using these models to really have a lot of confidence in the results that they're given. So this is where now people are now considering an alternative approach to kind of modeling language, building these AI systems that can actually address some of the limitations that I talked about. And the approach here, and the idea that a lot of researchers are exploring now, is try to model the dynamics of human language in terms of states. And what I'm going to talk about next are kind of two kind of different ways we can actually understand the states of these systems. So we're going to talk about state space models and then state machines. So I want you to imagine, take a minute for a second and imagine that you are driving a car. You're taking a road trip and you're driving a car. And at any given moment, your car can be in any state. Your state basically describes what the car is doing right now. So for example, the state could be the speed of the car, the direction that the car is going in, it's a position on the road. It can also be the amount of fuel in the vehicle, other relevant states, like condition that tells you the condition of the car at any given time. Now, let's say we want to predict where the car would be in the next minute. You'd need to know two things. First, you would need to know what the car is currently doing. That's this current state right now. And then you also need to know the inputs of your car. So the pressure of your foot on the gas pedal, whether or not you're applying any brakes to your car, the direction you're turning your steering wheel. Using that information, you can use that to understand, get a good understanding of where the car would go next in the next minute or next 5 minutes, and so on and so on. So that's basically essentially the idea of the state space model, what it's trying to capture here. So the idea is you're trying to model your state, the state of your system using differential equations, where based on that allow you to basically figure out the next position of your system based on input that is given at every instance. So this is an approach that's commonly used in many applications. So for example, control systems. Engineers typically use state space models to model dynamics in systems like robots, aircraft, circuits. It's also been used to predict future states of signals based on noisy observations, so like in common filters. And then it's also used in economics to model, let's say, time series data based on trends in data. Another way, so we have state-based models, and now the question now comes, and to a question that a lot of researchers in AI have been looking at, is can state-based models be used to predict the next word in input sequence? And it turns out the answer is yes. So this brings me to selective state space models, aka Mamba. And this is a variation of, it's basically the idea where you're taking state space models and you're embedding these models into layers of your neural networks. And what this gives you is some really nice properties that will actually address some of the issues with the transformer language model that I pointed out earlier. So one of the first properties is that you get fast inferencing because we're storing the state, we have a state that we're keeping track of. This allows us to, instead of having to look back at all the previous input that we've had in our input sequence, we can actually just keep track of our current state at every given time and use that to generate the next proper word in our input sequence. So that gives us faster inferencing. It actually turns out it scales, unlike transformers, which scales quadratically with your input sequence. With selective state space models, we can actually predict the next words faster because we're not having to look at all the words so if you look, going back to the analogy of driving a car, you only need to know where you were in the last minute in order to predict where you need to go to next. You don't need to know all the different look where you were at the beginning of your trip to figure out where you were going to go next. The other property that state space models provide is memory compression. And it's just really nice where you're dealing with problems or applications where you need to process a signal that coming in. You need to make a decision based on signals that are accumulating over time. So let's say, for example, you need to give me a clear example. So right. So let's say, for example, you have a real-time. So it's basically a real-time application where you have to, based on some new information that you receive, you need to make a decision, new decision based on all the data you've seen so far in the past. This is something you couldn't do with transformers, because transformers has a limit on how much data you can actually receive at any given time. But with models like selective state space models, what they actually do, they compress all this information that you've seen so far into a fixed state, which allows you to basically essentially the way it works is it's instead of, so the way transformers works is it's storing. It's basically storing all the words all the inputs that it's seen before, and it's using that to predict make predictions. The way Mamba takes a different approach, where it's not exactly storing all the information it's seen before. It's basically trying to figure out which information, the most important information, needs to remember in order to predict the next proper word in order to generate text. So essentially, the most recent information that is given is it remembers, and maybe information that it's seen that's been seen in the past, it forgets. So with in comparison to transformer language models, selected state models, theoretically, you can actually give it input of any given size, and it'll be able to process that data fine. So another property of selected state space models is this is what really makes it which is what really makes it work. Reason why it's able to generate text very well is selective gating. So there's these little structures that added into the Mamba block that allows it to basically select specific information in the input sequence to retain and to forget. So it allows Mamba models to perform tasks that transformers do very well, such as paying attention to specific text in the input sequence, so selective copying, or even making some induction tasks, where it's based on patterns in the input that it's seen, it's going to make some sort of inference based on it. So one of the things that I did was some of the results that I mentioned, I probably shared earlier during my research, was reproducing some of the early works, some of the results that were gained by some of the researchers that I was working on Mamba. So one of the benchmarks that I performed was taking some standard benchmark data sets that measured its performance on so there are several different data sets used to assess language models' abilities on, let's say, reasoning, guessing its performance on okay, let's take a step back. So there's several different benchmarks that's designed to measure the model's reasoning capabilities on certain contexts, like multiple choice questions. You give it a series of different multiple choice questions, and to rate how well the model is able to pick the right answer based on some context that is given, and other relevant benchmarks. And what these data sets are assessing is how well the models are able to provide the correct answers in many of these scenarios. So what you're looking at here is some of the results of the benchmarks I ran on the Mamba state space model and compared to some of the other similar transformer models of the same size and complexity. So in red, what you're looking at in red are two forms of Mamba models. There's a Mamba model that's 2.8 billion parameters, and then there's another more recent version of Mamba, which is a more recent iteration of Mamba that adds some more optimizations to improve its efficiency. And what you can see here is that the Mamba models perform really well in comparison to some of these similar transformer-based models on all these benchmarks. And then in terms of speed, so another benchmark that I've done was looking at its performance on speed. So what I did here was I took got a data set of text, and what I was doing here was testing the performance of the models, the amount of time it takes to generate text. Okay, so I took the models and I'm timing the amount of time it takes to generate text as a function of as I increase the number of input sizes. So as I increase the length of the text that are given. So when you look at the bottom here, the Mamba models are in red and purple. And what you'll notice here is as I increase the length of text given to the models, the amount of time it takes to generate the text is linear in comparison to some of the other transformer models that I've tested, where there's like more of a quadratic or kind of significant exponential increase in the time complex in the amount of time it takes to generate that text. So this is where I was testing. So I tested the accuracy of the models on some benchmarks and also the time. But then another question I had was trying to compare the performance of these state space models on more memory-based tasks. Because as I mentioned before, the way these models work is not remembering all the information. It's not keeping it's not storing all the information that it's given. It's basically doing some sort of compression. So naturally, there's going to be some piece of information that the model will forget. So what I was interested in here is just kind of getting a sense of how well does these models perform on more tasks that require you to actually retain information. So this is more like, say, for tasks like retrieving, where you're have given a context of data, of information, and you need to retrieve specific pieces of information from that context. So in this particular task, for example, it's called a phone book lookup task. There's I gave, so this is where I was comparing the Mamba models and a similar transformer model on how well it's able to retrieve a relevant number from a data set. So I gave it a data set of phone book entries. So it's a name, a list of names, and followed by the phone numbers. And then I gave it two examples of numbers of lookups. So a name of a person and a phone number. And what I was testing here is if the model will be able to actually retrieve the name, the phone number that's associated with the person's name, the query. So running this model, what I found was that so what you're looking at here is I tested this model against this task with 3 different variants of the models. What you see in red is the Mamba model in red, and then green is the Mamba 2 model, and then blue is the kind of a Pythia transformer language model. And one of the things you would immediately notice is that with smaller, when the phone book size, the size of the entries, so maybe I can step back. So what I did here is I increased the size of the number of phone book entries that I gave the model over time. So maybe I start out with a smaller phone book size of 10 entries, and then I try to measure how well the model is able to look up the numbers. And then I increased the number of entries in the phone book in order to kind of measure how well the models, these models are able to perform this lookup task as they increase the size of the context. What's immediately clear here is as the number of phone book entries increases, the performance of the state-space models kind of decreases a lot more gradually than the transformer model. And in a similar task, so that that task. So a similar task that I performed was measuring the ability of the models to actually copy, repeat text that it's seen before. So in this task, I gave it an input sequence, and I'm trying to get the model to basically repeat the same information that it's seen before, that was given an input sequence. And in a similar fashion, I observed kind of a similar behavior where as the size of the length of the text that I put into the model increases, the model's ability, the Mamba model's ability to kind of repeat the context, the same information in the input sequence decreased. Whereas with transformer models, they tend to be able to do a much better job of kind of retaining that context, again, because it's not throwing away any of the information that was given. It's basically keeping that context. So it's able to do it much better on certain tasks where that having that storage of information is really important. So okay, so now I'm going to switch gears, and I'm going to talk about state machines. So finite state machines are kind of a way you can understand how systems behave. So let's say, for example,
Daryl,
yes?
sorry to interrupt. Let me suggest, this was a 10, 15 minute slot.
Oh, really? Okay.
And yeah, as it has been for the last 60 meetings. So let's do this. Why don't we continue this in the after party if you've got time? Okay. This is super valuable work. The purpose, the reason Daryl is doing this, the reason that we're researching subquadratic models is to make AI smarter, faster, and greener. Currently, the pendulum has swung to one far extreme. In the 50s, 60s, 70s, the theories around language models was based on state machines. It was back, in fact, even in Victorian times, there were the notion that language, the theory behind language was state-based. There would be little textbooks called grammars, the rules of language. You learnt nouns and verbs and how to decline them and conjugate them and what would come next. And here's the structure of the language. And the computer scientists in the modern era, in the decade we're in, said, no, all of that doesn't work. What we're going to do instead is vacuum up all of the writing that we can find on the internet and then create monster models that try to just predict what the next word is. Okay, so that is the current prevailing thought, this notion that language has no structure. It is simply you need a big, massive model that runs in the cloud to predict what the next sequence of words are going to be given the previous ones. We think that that's unsustainable, and we believe the pendulum will swing to somewhere in the middle between these two extremes. I'm going to suggest, thanks, Daryl, so much. Sorry to cut you off.
Yeah, no problem.
What we'll do is we'll continue this if you have time in the after party. I'm gonna ask Myra if she can get us on schedule. There's quite a bit to cover.
Yeah, absolutely.
Yeah.
Thank you, Daryl. That was a great insight into everything you guys have been doing, especially with the fundamentals group. So thank you. Let's see. Let me go back. And I believe we are looking at work group updates now.
We're going to have a work group update, and we'll have an update on the front end. So someone from the front end group, if Bolage is there, if someone from Arcus Nexus
Yes, please.
is there, maybe they can give us an update. If not, I can do that. And we could also move to the PyOS update. And I hope I saw a picture from Sam and Patricia that they met in New York. I don't know if you've seen that online, but they've handed over to Robert Binning to give the update. So Robert, if you're there,
let me find Robert.
I don't see Robert. Okay, so let me take the mantle here. I want to talk about. Last week we were at IIW, and I gave you an update hot off the press because we came back from IIW on Thursday night, and so it was all fresh in my mind. And we did a great. I've been doing follow up, contacting all the various companies. Let me show you a snapshot of where we are, the milestones, and the traction we've achieved so far, and you can congratulate yourselves for a job well done. Here's the performance as the end at the end of October. We have actually, it's now about 680 members, but at the end of October it was 670 members. We've just launched the EMEA chapter maybe sometime before the summer, and then they went on a hiatus as the Europeans do. And yesterday we had a fantastic meeting with the EMEA chapter, and there are two initiatives that I'd like to call out. One is from Walter, and I see Walter Lundari, you're on the call. Where maybe later on you can talk. But Walter's developing his master's thesis, and the master's thesis is going to be on the subject of Kwaai itself, on the birth of a movement, and maybe go into the history of similar movements that hope to buck the trend in a dysfunction in an industry. And it's a dysfunction in our industry that we are facing. Look, even today, more than any other time, we need to let's go here. Today, more than any other time, we need to double down on the mission of Kwaai. The forces that are concentrating wealth and power, the forces of monopoly, are not going to be resisted. You can't rely on government to act in your interests. The likelihood is the government forces are going to encourage further monopolization in the AI industry. This is intensely dangerous. It leads to fragility and a lack of robustness in the economy when you have wealth and power concentrated amongst so few corporations. It's actually so few individuals. So what can we do to make a difference? There's no cavalry coming. You can't rely on the government to protect your interests, the privacy of your data. There's no cavalry coming. You are the cavalry. Kwaai and similar movements are the cavalry that hope to bend the arc of history, hope to resist the change that's coming on, resist this current headlong rush towards a dystopian future. Okay, I don't want to be too dramatic about that. Maybe I am. But we were in a similar situation 30 years ago in the server operating system space. And then that whole sector of the industry was controlled by maybe a half a dozen corporations. And we were in a state of no progress in the server operating system space. And then along came Linux, nonprofit, volunteer driven, open source. And now Linux is the dominant operating system. So we've got a template for how we can resist this monopolistic trend. And it is through the collective action of individuals like yourselves. We form a movement and then we take action. We don't sit back and just moan about it. Okay, so this is super important. I was sharing the updates of where we are, and let me do that again. It's and where we are and where we're going. So this slide over here, and let me make it a bit bigger. This slide I showed before. Look, we put a value on the donations, your in-kind contributions, your volunteer hours, plus also the in-kind contributions of the industry partners. For instance, the partners like iBridge, who are actually hosting our servers, the partners, the various platform partners that have granted us non-profit status so that we can use their systems. These are all important contributions. The pro bono contributions from the attorneys that help us. These are all valuable, and when we add up all of these contributions, so far we've clocked 8.1 million in terms of in-kind contribution. Look, that's hard cash. Even though it wasn't given to us in cash, if we had been a for-profit startup, that would have been money that would have had to have been paid. The vast majority of it would have been payroll. So we're immensely grateful to all of you for giving us your tired hours, giving us your time between jobs, and working towards moving the mission forward. Okay, so we wanted to talk about where we're going. Okay, so now more than ever, we really are thinking, where are we going? Where are we going as a movement? Where are we going as an industry? Where are we going as a society? Where are we going as a species? These are all, crazy esoteric questions, but they're not esoteric. I think this week, more than any other week, it's something that we're pondering. So I'm going to share a slide. Stop share. Let's go to sharing. We're back here, and I want to share the roadmap slide. Okay. Many of you have seen this before. I've updated it slightly, but it's important for us to understand where we're going. And let me just make that a bit bigger. The top line is the progress of the movement, Kwaai. This is where we are. We've launched, and this year it's about growing the movement, about forming the EMEA chapter and strengthening the board, which we've done. And we can pat ourselves on the back. We had said we were going to do 4 quarterly summits. That turned out to be a bit too ambitious. An annual summit is probably sufficient. And so we undertook a summit this year, and we've been asked by the conference organizers scale to come back next year. So I'm looking for anyone that wants to contribute and we'll be putting out a call for papers, call for contributions, and we'll be rounding up a much better cast of speakers than we had before. We've been asked to scale up our presence at the Scale Conference in Pasadena. So that's a date in March of next year. There's also going to be an EMEA summit in Venice, Italy in June of next year. So look out for that. And similarly, there'll be a call for papers. What are we going to be doing in the 3 years after from 2025 onwards? Well, we want to grow the organization. It's going to become global. And we want to end up in a state where we're self-sufficient. And we gain self-sufficiency by generating our own revenue. Non-profit doesn't mean non-revenue. Yes, we are asking for grants. We're applying for grants, and we are looking for donations from various funding sources. But I don't want us to be continually going cap in hand asking for donations. So to become a robust opposition to the monopolizing forces, we need to be generating our own revenue. So we're in this phase here in the development of personal AI. We're developing the educational beta, and we're itchingly close to having it running in the data center. We are working on the final DevOps automation to do that. It'll run, the beta will run for about a quarter, and then we will release the OS in time for the summit next year, so Q1 next year. And we will be inviting third parties to develop applications for it, and we'll be nurturing that sort of innovation movement through hackathons in order to get that going. And that will generate revenue for us. It's not the type of SaaS revenue that the existing oligopoly are salivating about. The broad concept is, this will be AI for you for free if you host it yourself. If you want us to host it, we'll pass on some of that charge, and we will, and that'll be a source of revenue for us. And so that is the main track that we're on. The rest of our energy, about 10% split between research, and you saw an example there of the research output. There's more research papers coming, and then there's also a policy group that is that has its own list of initiatives. I'll stop there. And back to you, Myra. I think we'll hear from you.
So I think I did see Balaji join. So I don't know, Balaji, if you do want to give an update on the Pi Assistant.
Or we can move to new member voices.
Yeah, let's do that. New members, please.
I see some new participants, and we'd love to hear from them. For instance, Matthias Bennett. Yeah, I think you're new to the organization. It'd be lovely to hear from you. Yeah. Tell us what brings you to Kwaai.
Well, thank you. First of all, it's a pleasure. Really appreciate your sharing, Reza, and it's quite impressive what you all have worked on and completed up until now. I was introduced by Ira Liss, who is, at least in the Zoom, right in the square right underneath. And we had a great touch-in conversation. So, well, I'll see if I can nutshell it. I have a background in technology since the late 90s, more like web development. In 2011, I asked myself, what do I truly need to be a happy human? And then I moved to an island and did work trade and slept in a tent for a year on a friend's land and received these principles of leading with courageous vulnerability. And I've shared those in various ways, most notably in Morocco, where I was there from 3 years, from 2016 to 2018. And I shared that message across various stages, from young entrepreneurs and major financial corporations, and supported in the start of a set of organizations that have basically supported over 57,000 young entrepreneurs to date.
Wow. Okay. Well, really grateful to Ira for the introduction. And look, go sign up at Kwaai.ai. It's free to join. I'd love to get you engaged on the Slack conversations, but separately, you and I should probably schedule a call. Thanks so much. Some new faces on the call as well. Actually, Rob, Aaron, you've been on the call before, but we haven't heard from you in a while. Rob, I think we met at IIW back in March, maybe.
Yeah. It's been 6 months, and then I saw you and Ruth last week again. Met Sam. So yeah, I've been dipping my toes a bit. I'm kind of in that space between decentralized identity and what Doc Searles is working on with his project VRM. So it was really great seeing Consumer Reports there on Monday, and they have some good things going on. So personal AI for me is finding products, finding goods and services, and empowering um, providers of goods and services to make that available, because we have to bypass traditional search to actually have personal AI be able to find things for us. And so I'm looking to flip the paradigm a little bit, and so I'm seeing where this is going. I was a semantic web guy back in the day. And decentralized identity and SSI was missing. So I kind of had a career doing other stuff for the last 15, 20 years. And so I'm back giving it a go with personal AI and decentralized identity. It's going to be a great combination.
Fantastic. Thanks, Rob. And yeah, I think you mentioned Consumer Reports was at IIW and Project VRM. It shows that this movement is getting momentum. Yeah, it's a long play, and we didn't find the people that are rushing to the red ocean, all the investors and the big brands that are rushing to the red ocean of corporate AI and enterprise and SaaS platforms. Great, let them go there. We have the luxury of being able to play the long game, and I think we're going to be the winners in the end. Okay, so look, 6 minutes, coming to the top of the hour. There's an after party after this. Myra, I wonder if you can post. You're right there. Myra's posted the coordinates for the after party. And this is where we do a deep dive into what the guest speaker was presenting and pick one or two other topics. So come to that as well.
You're going to be able to come so you can continue.
Fantastic. Thanks so much. And Daryl, sorry for cutting you off there. I know you're in a flow. There are a few more speakers we can hear from. Duval, maybe you want to speak up. And Sweta Rao, gosh, I met you at IIW twice now. I think you need to come on camera and say hi. Yeah. So any one of you.
Hey guys, how you doing?
Hey.
Yeah, I'm Don. I do a lot of work with knowledge graphs and ontology, particularly the ontology. I look at ontology sort of like when Reza was speaking about the philosophy of AI. When we look at sort of like the genealogy of morals between the master being in the, let's say, like the open AIs as the master, and we would technically fall under the people that are looking to not be controlled by larger corporations.
Yes.
So that's the work that I do, is looking at what's the ontology of upward mobility. How do we use AI for ourselves, for our families, and for society?
Fantastic. Well, you'll find a home here. Sign up at Kwaai.ai, just become part of the Slack groups, and I think there are one or two work groups that you would enrich by your participation. We've got a few others. Bri, you and I had a call this morning. Maybe you want to come on camera and just say hi to everybody. Tell us what you were talking about.
Yep. So what Duval, I don't see your first name, but anyway, knowledge graphs, total jam. We can totally jam out about that. What I was discussing with Reza this morning was just getting more getting aligned on kind of a data model and a roadmap by which we can actually increase the accuracy of the virtual private RAGs and make them verifiable, et cetera, so that we can locally create maps and trust them and actually make personal AI verifiable and work for people.
Fantastic. Okay. Well, look, we're at the top of the hour.
If there's time.
Sweater, come on, tell us what's up in your world.
Hi, everyone. It's a pleasure to be here. My background is in scaling initiatives that enable equitable growth. I've been working closely with Beacon Protocol. I was a part of their core team. I helped them initiate and scale a lot of the open networks in e-commerce, mobility, and edtech. I also helped them with community building, laying the foundation for the volunteer group there. I'm a computer science engineer who fell in love with cracking narratives and making initiatives that matter more relatable and understandable to the audience. And I love that I'm here and super excited to be involved.
Sweta, this is wonderful. I enjoyed our conversations back in April, and then again when I met you again this time. I think we've got more and more alignment, and our need. There's a relevance between your experience and our need. The fact that you got this deep experience in the Beacon protocol, I think that's going to be a key ingredient into us building the intent casting network that we described. So looking forward to your participation. Okay, I think it's time for us to hop to the after party. So thank you so much. Thank you so much. The 68th Kwaai Day. This is great. Next week, we've got a guest speaker. It's Matt Bird, who's the CEO of ESG News. So ESG News is the premier news outlet for sustainable technology. And he's going to be our guest speaker. So I'm looking forward to that. But let's hop to the after party and dive deeper into the subject matter that Daryl was talking about. Thank you very much. Happy Kwaai Day.
Thank you.
Bye. Bye.